Now our friend's code is incorrect. So what we're going to try and do is debug it. We're going to try and get rid of the errors in the code. Now I'm going to show you how we're going to debug this code, not in the REPL, because in the REPL, once you type something, you can't go back to it. So instead, we are going to edit this code in a code editor. I want to point out that each one of the two statements that our friend wrote is by itself perfectly correct Python syntax, meaning according to the grammar rules of the Python language, there is no error in a statement like this. This is a perfectly legal Python statement according to the grammar rules of Python. And then on line 2, this is a perfectly legal expression in Python according to the grammar rules. The problem is when you write this second statement after the first statement, as we saw, then if you try and run this Python code, you will get an error on line 2. So we call this a runtime error. There's nothing wrong with the syntax, with the grammar rules, but when we connect these two statements together, we see an error. So this is the error that we're now going to try to fix. We will fix this on Python Tutor. So here we are with the same code on Python Tutor. I am in a code editor and I can modify any parts of this code. But before I do that, let me point out a few important things. Firstly, notice that in Python Tutor by default, we are using a version of Python called 3.11. There is an older version, 3.6, which we will avoid using, and there are more modern versions of Python. At the time when I'm recording this video, the most modern version is 3.13. But all these are flavors of Python 3, which is the language that we are learning. So before we debug this, let's run this code and reproduce the runtime error that our friend got in the REPL. So we'll scroll down to Visualize Execution. Notice I have used the non-default visualization so that it's easy for us to see how variables are assigned to objects. So I click on Visualize Execution, and it is ready to run the assignment statement. Now, the way an input function is called in Python Tutor is slightly different to what you will see in the REPL. Here, it actually prints out this nice text box. The string that was given Celsius : space is written over here. And here, there's a little text box which I can interact with. Remember, we're doing this in the browser. So now I will type in the same thing that my friend typed in, which was -40. I'm just typing in -40. I'm not putting any quotes around it. I click on Submit, which is like pressing Enter. And now the visualization looks like this. It says temp in Celsius refers to a string object which is -40 in quotes. In the REPL, we saw in the REPL, if you were to take a look at the string, you would see it in single quotes. Here it's in double quotes. Remember, this doesn't really matter as long as you use the same type of quotes to begin and end. So this concludes the first line. The first statement has executed successfully. The red arrow has moved to line 2. And that is where we are actually calculating this expression. Now remember, temp in Celsius is a string, and multiplying a float with a string is illegal. So when we click on Next, we get the same error message that our friend got. Type error, can't multiply sequence by non-int. And that error is indicated with these red bars. So now we should go and debug this code. Let's click on Edit this code and take a look at how we will try and fix this. We know that this first line is going to result in a string object. In order to do these kinds of mathematical operations, we have to first convert the string into a float. So what I would like to do is I would like to take my temp in Celsius, which is a string. Let me copy that by pressing Ctrl C. I would like to take that string and convert it into a float. Is there a built-in Python function for converting strings into floats? Well, it's not actually a function as we have seen, but we are going to treat it like a function. There is a function called float which will convert anything that you give it, including a string, and it will at least try to convert that into a float. So the object that results from this function call will now be of type float. But I must capture that object. I must capture that object by assigning it to a variable. I'm just going to recycle the same variable that I had on the previous line. So let's see what this code looks like. I will click on Visualize Execution, and we will type in the same -40 for the input. And then the assignment statement will assign temp in Celsius to the string object -40. Now, when we click on Next, we are going to execute the second assignment statement. This will convert the string into a float, so observe what happens in the visualization when I click Next. That became a float. What happened to the string? Well, go back and see. The only variable that was referring to this string object was temp in Celsius. But now the second assignment is moving that variable to a different object. When this variable moves to a different object, no other variable will be assigned to this string object, so it's being cleared away. And now temp in Celsius is a float. Since it is a float, we can do calculations with it, including multiplying it with 1.8 and adding 32, and that should produce an answer. But where is that answer? All that we have on line 3 is an expression. What we're going to do is change this to actually display or print the answer. So I click on Edit the Code, and instead of simply calculating this expression, I take this expression, the resulting value, and I print it. So there is a helpful built-in function called print. And I must remember to put the surrounding brackets, otherwise I will get a syntax error. So here's what I'm saying. Take this expression, evaluate it, and whatever object you get, print that out. And the print function will try and show this to us. So I'll try it one last time. -40, hit submit. That produces temp in Celsius, which is a string. Click on Next. That converts temp in Celsius to a float. And now print this float. So when I click on Next, I want you to observe what happens in this box, which is where the print output will be shown. So I click on Next, and it prints -40.0. It turns out that -40 Celsius also turns out to be -40 Fahrenheit. So this calculation is correct. I'm sure you can tell me why this is being printed as -40.0 and not just -40. The answer is that this expression evaluates as a float. Why is that? Well, temp in Celsius by this stage is a float, or rather it references an object which is of type float. So this is the multiplication of two floats. When we take the resulting float and add an integer to it, the result is of type float, and that is what gets printed.